Hello everyone, happy Monday. Today we have an isotope activity for you. We mentioned this word isotope last week a little bit, but now we're going to start to explore what it actually means to be an isotope and how we can calculate what specific isotope's mass number is. So make sure that you pulled in the assignment or the document from the assignment in Schoology, and it's in your chemistry subject over here. Remember, we want you to stay organized, especially as we're transitioning into distance learning. We need to have those subjects ready to go. So here's our activity, and we're going to start out learning about what isotopes and mass numbers are. So an isotope, if you remember from Mrs. Konitz's video last week, is a version or flavor of an atom. And all of these atoms are from the same element, okay? So it's a different type, it's a different flavor, it's a different version of an atom, but it comes from the same element. So isotopes have the same number of protons, and that makes sense, right? Because it's coming from the same element, and all chlorine elements have the same number of protons, all strontium have the same number, all argon have the same number of protons. But they have a different number of neutrons, making each of them have their own specific mass number. So, if you remember from the PhET activity, there was that mass column on the right, and the only two particles that actually changed the mass was the proton and the neutron. And that mass that you got over there is what we call the mass number. So an atom's mass number is specific and determines which isotope or which flavor or version of the atom you are working with. Mass number, this is how we calculate it, mass number is the total of protons plus neutrons. And hopefully that makes sense because of that PhET last week. If you add a proton and add a neutron, your mass number would be 2. And if you add 50 protons and 50 neutrons, your mass number would be 100. And now here's the key thing. The mass number cannot be found on the periodic table. So if it is known, it will be shown with the element name. So you're probably sitting there, Mr. Mahadi, well, where am I supposed to find the mass number? Well, let me tell you. Either we have to give the specific isotope to you, so we will tell you what the mass number is, or we will give you enough information with protons, neutrons, and electrons to figure out the mass number. So let's do an example here. If I tell you the isotope is hydrogen 2, that's how we would write it, that specific isotope. And this 2 is the mass number. So same thing for chlorine here. Cl, and it's 38. So the mass number for this isotope of chlorine is 38. Now same thing with carbon, carbon 14. That 14 is the mass number. So we can give you something and just say carbon 13, and you know that the mass number of that isotope is 13. All right. So hydrogen can come in many different varieties. So this is one that has multiple different isotopes. Each isotope has the same number of protons, right? Of course, it's hydrogen. It only has one proton. But each has a different number of neutrons, making the mass number bigger or smaller for each variety or flavor. They are all still hydrogen, but different total mass. So let's complete these examples. So we know that it's hydrogen 1, so this would be your mass number. Now if I'm looking at this atom, I know it's hydrogen, so I have one proton. Could put a plus in there as well. So I have one, oh, we can try to put a plus in there. I have one proton, and if my mass number is 1, and I have one proton, how many neutrons do I have? I can't have any, because my mass number is 1. Now let's jump to this second example here. So this is hydrogen blank. We need to figure it out. I have one proton, and then this purple ball over here is a neutron. So I have one proton because it's hydrogen, has to have one proton. And this other particle right here, this one's in the nucleus, so we know that it has to be a neutron. So I have one neutron. If I have one proton and one neutron, that's going to give me 2. And that is our mass number for this one. And now for this third example. We need to create hydrogen 3. So we know that if we add protons plus neutrons, it has to equal 3. That's how we find our mass number. So let's see if we can write this in here. I know I have to have one proton. Have to have one proton. Because it's hydrogen, I have to have one proton. And then, if I have one proton and the mass number is 3, that means I need 2 neutrons. So let's mark these up here. 1 proton, 2 neutrons. And then, of course, I would need lots of color changing here. An electron over there as well, because it's a neutral atom. So I have 1 proton, 2 neutrons, and that gives me the mass number of 3. And you are going to have to practice that below. So let's do one more example here before we get you going on this part of the assignment. So it says fill in the number of protons, electrons, and neutrons for one atom of each of the following elements. Use the mass number along to the side to help you guide your calculations. Include the number for the element's group and period, and as you can use your periodic table. Okay, so let's go through the hints up here, or the keys up here. Number of protons. Our hint, because we know number of protons, is the atomic number. Number of protons is the atomic number. We can find that on the periodic table. Number of electrons. This is kind of an interesting one. If everything on the periodic table is a neutral atom, that means that everything on the periodic table, as it's found on the periodic table, has the same number of protons and electrons because it's neutral, right? So that means that this is also the atomic number, which is pretty easy for us because that means that these two are going to be the same. Now neutrons is a little different. Remember from up here, we have to take mass number and we would have to subtract our protons to find neutrons because protons plus neutrons equals mass number, so I'm just changing that equation around. So this is mass number minus protons gives us number of neutrons. Okay? So let's take a look at strontium here. So it's strontium 87. This is our mass number. So if we go back to our periodic table, I need to find strontium. Yep. There it is, right over there. So I see the atomic number for strontium is 38. Switching back, 38. Well, this says that the atomic number is the number of protons and electrons, so I know that it's 38 for both of those. Okay, now thinking about strontium and trying to figure out my number of neutrons, it says mass number minus protons equals neutrons. So I have mass number, which is 87. I need to subtract the protons, which in this case is 38. 38. I need to do some math. 17 minus 8 is 9. 7 minus 3 is 4. So my number of neutrons is 49. So 38, 38, 49. Now we're not done. There's one last thing we have to do. We need to find out the period and group of strontium. The more practice you can get with this, the better. So I'm going to start with period. Remember, periods are across the rows across the periodic table. So this one says it's in period 5. And then groups are these columns. And it says we are in group 2. So period 5, group 2 for strontium. Period 5, group 2. And that's all we need to do for that part. You have some more questions down here, some more practice looking at some different isotopes, and you are going to compare atoms or known isotopes of each other, And then down here, you're going to fill in a table, but now you have some mass numbers and some elements that you have to fill in as well. So a little bit trickier. And then this one is key down here. Differentiating mass number and atomic mass. Okay? So work through the rest of this. There will be a key posted so you can check your answers, but go through, do your best. Ask your teacher if you have any questions.